Hello there guys, so here another video is up for pressure measuring instruments. So I am here again, Engineer Jewel Ryan Nicole Villariosa at your service. So you will be seeing here the different images of pressure measuring instrument, but then I will be discussing or focusing more on 5 specific pressure measuring instruments. So let's go. So first we have here a simple gist or summary of what we are going to do for today. So we have here the introduction of for pressure measuring instruments, and then examples. As what I have said, we have 5 specific examples to be discussed, and then of course brief definition or description, and then how does it work, the principle of operation, and then the features of this specific instrument. And of course, at the end of the day, you will be realizing how important these instruments are. So let's start. So first of all, we have here the introduction. So I want you to be knowledgeable about pressure measuring instruments. So these are the instruments, of course, used to measure and display pressure in an integral unit. So in simpler terms, pressure measuring instruments are instruments used to measure pressure. Usually they are also called pressure meters, pressure gauges, or vacuum gauges. So we already defined the pressure measuring instrument. They are used to measure pressure. But then what is pressure? So pressure is defined as the physical force exerted on an object. In mathematics, pressure is force over area. This is the force applied or is perpendicular to the surface of objects per unit area. One trivia, the standard unit for pressure is Pascal, which is Newton per square meter. I hope I properly introduced to you pressure measuring instruments and pressure. So let's now start with a specific measuring instrument, which is manometer. Manometer is defined as one of the earliest pressure measuring instruments due to its inherent accuracy and simplicity of operation. For me, when I think about pressure measuring instruments, I really think of one of the things or one of the instruments that I really think is, or I really remember, is manometer. So one trivia, manometry measurements are functions of gravity and liquid density. Both physical properties, so gravity and liquid density, both physical properties that make the YouTube manometer a major standard for accuracy. Also, the most famous manometer is the YouTube manometer. So, principle of operation. As you can see in the figure, this indicates how the difference in column heights indicates the difference in pressure. As shown in the left, with each leg of a YouTube manometer exposed to the atmosphere, the height of liquid in the columns is equal. With this as the reference and connecting each leg to an unknown pressure, the difference in pressure will now be determined. So, features of our YouTube manometer. A manometer can be designed to directly measure absolute pressure. So, we have different kinds of pressure, but a manometer can be designed to directly measure absolute pressure. Also, the most common form of this manometer is the conventional mercury barometer. So, mercury barometer used to measure, again, atmospheric pressure. So, next we have Bourdon tube. Another pressure measuring instrument. The Bourdon tube is a thin tube emanating from the socket fitting upward and along the inside edge of the gauge housing. So the name Bourdon was derived in honor of Eugene Bourdon, a French watchmaker and engineer who invented the Bourdon gauge in 1849. So the Bourdon tube is named after Eugene Bourdon, the one who invented it. So here we have the principle of operation. How does a Bourdon tube work? The Bourdon pressure gauge operates on the principle that when pressurized, a flattened tube tends to straighten or regain its circular form in cross section. So the Bourdon tube comes in almost helical and spiral shape. So we have C-shaped Bourdon tube, we have helical Bourdon tube, and then spiral shape Bourdon tube. Although most gauges employ the C-shape, so meaning the most popular kind of Bourdon tube is C-shape, which is the type of Bourdon tube actually in the picture. That is a C-type Bourdon tube. Features of the Bourdon tube is when a gauge is pressurized, the Bourdon creates the dial tip travel to enable pressure measurement. Bourdon wall thickness and diameter are key considerations for enabling the required tip travel to traverse the necessary movement and thus facilitate pressure measurement accuracy. The higher the pressure requirement of the application, the safer the Bourdon tube needs to be. Again, the higher the pressure requirement of the application, the stiffer the Bourdon tube needs to be. So, earlier we discussed Bourdon tube in general. Now we are focusing to the one of the most common shape of Bourdon tube, which is the C-shaped Bourdon tube. So, brief description. The C-shaped Bourdon tube has a hollow elliptical cross-section. It is closed at one end and is connected to the fluid pressure at the other end. So, that is one characteristic of our C-shaped Bourdon tube. The principle of operation, when the pressure is applied, its cross-section becomes more circular, causing the tube to straighten out, like a garden hose when the water is first turned on, until the force of the fluid pressure is balanced by the elastic resistance of the tube material. Since the open end of the tube is anchored in a fixed position, changes in pressure move the closed end. A pointer is attached to the closed end of the tube, although a linkage arm and a gear and pinion assembly which rotates the pointer around a graduated scale. So a pointer is attached to the closed end of the tube through a linkage arm and gear and pinion assembly, which rotates the pointer around a graduated scale. So that's its principle of operation. The features: a red hand is available on some gauges and is manually positioned at the maximum operating pressure of the system or portion of the system in which the gauge is installed. Bourdon tube pressure gauges are used in many hydraulic systems. That is why they are usually referred to as hydraulic gauges. So that's the main importance of Bourdon tube pressure gauges for hydraulic system. That's why it is termed as hydraulic gauges. Another instrument is diaphragm pressure gauge. Brief description of this instrument. A diaphragm pressure gauge is a device that uses a diaphragm with a known pressure to measure pressure in a fluid. The diaphragm has a flexible membrane with two sides. On one side is an enclosed capsule containing air or some other fluid at a predetermined pressure. The other side can be left open to the air or screwed into whatever system the gauge is meant to measure. Again, the diaphragm has two sides. One side is an enclosed capsule containing air or any other fluid at a predetermined pressure. Then the other side can be left open to the air or screwed into whatever system the gauge is meant to measure. So features. First we have to tackle about the principle of operation. A fluid in contact with a flexible membrane pushes on the membrane, bending it. The pressure is a measure of how hard it pushes. As the outside pressure increases, it pushes back on the membrane, bending it back the other way. By measuring how far the membrane bends, the gauge can detect the outside pressure. So the gauge can detect the outside pressure by measuring how far the membrane bends. So it depends upon the bending of the membrane. So here we have the features. It has many different uses such as monitoring the pressure of a canister of gas, container of gas, measuring the atmospheric pressure, or recording the strength of the vacuum in a vacuum pump. And then we have the Bellows pressure gauge. Brief description of the Bellows pressure gauge. Bellows gauge contains an elastic element that is a convoluted unit that expands and contracts actually with changes in pressure. The pressure here to be measured can be applied to the external or internal part of the bellows. Again, the pressure to be measured can be applied to the external or internal part of the bellows. However, in practice, most bellows measuring devices have the pressure applied to outside of the bellows. In practice, again, most bellows measuring devices have the pressure applied to the outside of the bellows. Principle of operation of these bellows. Most bellow gauges are spring-loaded. That is, a spring opposes the bellows, thus preventing full expansion of the bellows. Limiting the expansion of the bellows in this way protects the bellows and prolongs its life. So, in a spring-loaded bellows element, the deflection is the result of the force acting on the bellows. Again, the deflection is the result of the force acting on the bellows and the opposing force of the spring. So, here we have the features. Like Bourdon tube elements, the elastic elements in bellow gauges are made of brass, phosphor bronze, stainless steel, beryllium copper, or other metal that is suitable for the intended purpose of the gauge. Although, some bellows instruments can be designed for measuring pressures up to 8,000 pounds per square inch gauge. Their primary application aboard ship is in the measurement of low pressures or small pressure differentials. So that is all for the part 1 of our pressure measuring instruments. If you wish to have a copy of this PowerPoint presentation and if you also have some questions regarding the topic, kindly email me at ryannicole05@gmail.com. Thank you very much and see you to my next videos. Thank you. Keep safe.